section 5.3. Instead of just probability distributions, a type of probability distribution, a binomial probability distribution. Now, binomial, bi means two. So, for a binomial probability distribution, we want there to be two different types of outcomes. All right. Your book says such as acceptable, defective, survived, died, heads, tails, pass, fail, true, false, binomial. Okay, so we need some type of trial that has two different outcomes. Now, if we have a probability distribution, then here are the different characteristics that a binomial probability distribution would have to meet. The procedure has a fixed number of trials, like, okay, I'm going to flip a coin 1,000 times. It has a fixed number of trials. The trials must be independent. So, one trial can't depend on the other trial. Each trial must have all outcomes classified into two categories, commonly referred to as success and failure. So true, false, you would think of maybe trues as success and false as failure. Maybe. I guess depending on how you really use that. If you were taking a test, it probably success would be getting the problem right, and failure would be not getting the problem right. Maybe you want to know the probability of getting so many heads when flipping a coin. Well, then the probability of getting heads, that would be the success, and the probability of getting tails would be a failure. But let's say that we did another experiment. We wanted to know the probability of getting so many tails out of 500 tosses of the coin. Well, then tails would be the success, and heads would be the failure. So it really just depends on what type of problem you're looking at. All right. So these three conditions must be met to have a binomial probability distribution. Fixed number of trials. Trials must be independent, and you must be able to classify the outcomes into two different categories. All right. S and F, or success and failure, denote the two possible categories of all outcomes, P and Q. All right, P and Q, these are very important concepts. P and Q. P is the probability, lowercase p, the probability of success, and Q is the probability of failure. Now, if we know P, the probability of success, the way that you figure out Q is to say 1 minus P. So think about this like, let's say that the probability that it was going to be sunny today was a 0.9 or 90% chance of it being sunny. The probability of it being cloudy then would have to be 1 minus 0.9, which is 0.1. So for that scenario, P would be 0.9, Q would be 0.1. When you add P and Q together, when you say P plus Q, that's the probability of success plus the probability of failure. So that has to be equal to 1. So P, that's success. Q will always be, or failure, will be 1 minus P. Pretty easy to remember. All right. Okay. All right, so we're getting ready for the binomial probability formula. To understand the binomial probability formula, which we'll get to eventually, we're going to have some n in the formula. That's the number of trials. X will be the specific number of successes in n trials. So X can be any whole number between 0 and n, meaning if I flip a coin 500 times, then n equals 500. X can be anything between 0 and 500, whole numbers. Okay? You've already written down that lowercase p means a success. So lowercase p is success in one of the trials. Q denotes the failure in one of the trials. Okay? Capital P of X, remember that's the probability. Probability of it getting exactly X successes in n trials. Okay?
What is it, the probability of getting what now?
X successes out of n trials. Nothing really new. We went over, or we've already, we've used that in probability. Just, like P of 3, that will be the probability of getting 3 whatever out of ever how many trials. Like that. Okay. Be sure that X and P refer to the same category, being called a success. So like, if I want to know the probability of me having a girl out of 3 births, assuming that births are the same, the birth rates are the same for girls and boys, then probability of 1 girl out of 3 births, you need to make sure the probability of 1, that's talking about having a girl. And P, the success of having a girl, will need to be 0.5. You just need to make sure that the X, whatever you're talking about in the problem, and the lowercase p that you use in the formula we're about to cover relate to the same thing. All right. When sampling without replacement, consider events to be independent if the number of trials is less than 0.05 times capital N. This would be like, it says without replacement, but this isn't really going to affect you and your problems. If it does, we'll come back to this. It's just a little extra they have there. All right, let's read through this example. When an adult is randomly selected, there is a 0.85 probability that this person knows what Twitter is. Suppose we want to find the probability that exactly 3 of 5 randomly selected adults know of Twitter. Does this procedure result in a binomial distribution? Okay, so we have 5, it says 3 of 5. So that's 5 trials. We're going to go up to 5 different adults. 5 trials. So that means that n is equal to 5. Each trial has 2 outcomes. Well, either the person is going to know what Twitter is, or they're not going to know what Twitter is. There is a constant probability of 0.85. All right? So, does this procedure result in a binomial distribution? Yes, it would. All right. Probabilities. And we're getting closer now to the actual binomial probability formula. Now, there are a couple of different ways that you can find the probabilities of a random variable x in a binomial distribution. One of the ways is by using the actual formula. Okay, so this is on your formula sheet, the insert from your book. So we have the probability of x. So this is a set number of whatever you want. So like going back to the 3 births out of 5. The 5 would be your n. Notice you have an n factorial on the top. The 3 births, the 3 would be your x. So this right here is n minus x. So that would be 5 minus 3 factorial. And then times 3 factorial. Now here's the part that usually confuses students a little. You know, not only do you have to do this and simplify the factorials, then you have to say times p to the x power times q to the n minus x power. Remember, this p right here, this is the probability of a success. So if you go back to the births, this lowercase p would be a 0.5. X, how many of those births did we want to be, say, girls? 3. So this number right here in the formula, these two x's down here, and this power have to be the same. This n minus x right here, that's the power for q. It's q, whatever the probability of failure occurring, to the n minus x power. Okay, once you plug all those numbers in, you work out the left side, then say it times whatever this is, times whatever this is. Don't round any of it. You know, don't round any if you can avoid rounding. All right. All right, here is the second method, using technology. So if you can use StatDisk or Minitab or a TI-84, if you know how to use those, then there are ways to work out the probability of a binomial distribution. Those would be like shortcuts. Here's the third way. The third way is not always going to work, but when it does, it's the quickest way, in my opinion. It's even quicker than plugging values into a calculator. Okay. Appendix A in the back of your ebook is a list of the binomial probabilities table. Now, here's why you can't always use this table. Notice that there are several columns for different values of p. P is the success of your trial. So if your p, or the success of your trial, is not listed in one of these as one of these values under p, then you can't use the table. So like for heads or tails or boys or girls, usually we use 0.50, or we have so far. So we could use the table if our trials were flipping a coin or having births or something like that. But let's say that our trials, like with the Twitter example, p was 0.85. You remember that? The probability that an adult would know what Twitter was 0.85. Well, there's no p 0.85 here. There's a 0.80 and a 0.90. So we wouldn't want to use these tables for that problem. But if it's something like having births, I'll show you how to find the probability, assuming that the probability for having a boy and a girl is the same. We can find the probability for exactly three girl births out of 5 really fast using this table. What you do, n is your number of trials. So go down to where n equals 5. Notice that under n equals 5, you have 0 through 5. That's your random variables. Then go over to the probability of a success. Well, assuming that the probability of having a girl is 0.50, or 1/2, we use this column. Now, we want exactly 3 births. That was an example we looked at earlier. So 3 births go over to the 0.5 column. Here's the probability of having exactly 3 girl births out of 5 births. 0.312. So you can see, I mean, that's even quicker than if you punched all this in your calculator and figured it out. Using the tables works really fast as long as the probability of your success is at the top. Okay. Again, you can find this table if you go into your ebook, go to the back matter. It's the very first. It's Appendix A. If you want to print that out, then feel free to use that on the test. All right, which brings us to this. Look at this. We just went over the binomial probability formula. So let's use the binomial probability formula to find the probability of X successes in N trials given that the probability P of a success on a single trial. So here's our N, here's our X, here's our P. The only thing I don't see down here is your what? Q. What is your Q?
1 minus P.
That's right, 1 minus P. So 0.75. All right? So we need to remember that formula. It's N factorial over N minus X factorial times X factorial times P to the X times Q to the N minus X. All right, so the probability of exactly 5 of whatever this is equal to 12 factorial over, what's that? 12 minus 5 factorial times 5 factorial times 0.25 to the 5th power times 0.75 to the what? 7th power, right? Because it's N minus X, 12 minus 5. All right, so I would suggest simplifying a little bit here. Remember that 12 minus 5, that's 7 factorial. So what I would do is I'd say 12 times 11 times 10 times 9 times 8 times 7 factorial. And that way, if you do that, you can cancel the 7 factorial out on the bottom. Okay? And then you say times 0.25 to the 5th times 0.75 to the 7th. Okay? So bring up a calculator real quick. So I have 12 times 11 times 10 times 9 times 8 divided by, what I'm going to do is I'm going to divide by 5, divide by 4, divide by 3, divide by 2. That's 5 factorial. So divided by, and I could do that, or I could just in parentheses. I don't even know if I'd have to put in parentheses. I'm looking, there's a factorial button right here. I'm just going to put it in parentheses anyway. So parentheses, 5 factorial, close parentheses. All right, so this first part here gives me 792. Okay, I'm going to keep that number in my calculator for a second, 792. I'm going to say this times 0.25 to the 5th. So the way you do 0.25 to the 5th, usually when raising to a power, you look for an x to the y or a y to the x button on your calculator. So say times, and then on this calculator I'm using, it has an x to the y. Lots of calculators have y to the x. It means the same thing. So I'm going to say times, now I'm going to put, again, I like to put things in parentheses usually. So parentheses, 0.25, close parentheses, raised to the what? 5th power. Okay? So that's going to give me that, times that. Now I want to say this times 0.75 to the 7th power.
So you just leave it as the same number?
Yes. Oh no! Alright, I do need to, I'm going to have to, I didn't push the power button, so 0.7734,375. 375 times, I didn't do this right, so 0.75 raised to the 7th power. As long as you're using the Windows calculator, it kind of tells you what you're doing, so it will follow the order of operations. Alright, so there's the probability of exactly 5 successes out of 12 trials of when P equals 0.25 and Q equals 0.75. So, looking at my answers here, if I rounded to 3 places, looks like it's going to be A. Alright, so P of 5 is equal to 0.103. Alright. Alright, so that finishes up those problems we were looking at. Alright, let's go back to the slide here. Alright, here's this was 3 of 5 with 0.85. This is that same example that we were looking at earlier. Given that the probability is 0.85 that any given adult knows of Twitter, use the binomial probability formula to find the probability of getting exactly 3 adults who know of Twitter when 5 adults are randomly selected. Okay? So, let's plug these into the binomial probability formula. Exactly 3, so it's going to be P of 3 is equal to, remember it's n factorial, so 5 factorial over n minus x factorial, so it's going to be 5 minus 3 factorial, which is 2 factorial, times x factorial, so times 3 factorial, times p, which is 0.85, raised to the x power, that was 3, times q, 0.15. I don't believe we were given that, but you could figure that out from 1 minus 0.85, right? So it's 0.15 raised to the n minus x power. So it's just going to be 2. All right. So this is going to be, I'm going to say 5 times 4 times 3 factorial. I'm going to stop there because I do have a 3 factorial in the denominator. Those will cancel out. Alright, so that's going to be 20, and then 2 factorial is just 2 times 1, so 20 divided by 2 is 10. So say 10 times 0.85 to the third times 0.15 to the second. Alright, so 0.85 raised to the third. You might want to put your 10 in first, but I'll put that in first, so it don't matter. I can say that times 10, and then say that times 0.15 to the second. So I'm going to say times 0.15 raised to the second. Alright, so if we round that to 3 places, that will be a probability of 0.138. Probability, and this is of exactly 3. 0.138, and that's rounded, of course. Now, what if this problem would have said, what is the probability that at least 3? So the problem we worked out said exactly 3. But what if I change this to at least 3? What does at least 3 mean? At least 3 is the probability of that x is greater than or equal to 3. That's one way to write that. Another way to write that is probability of at least 3 of 5. But what does that actually mean? That means the probability of 3 plus the probability of 4 plus the probability of 5. So if I wanted to know the probability that at least 3 adults know of Twitter with this given success rate and fail rate, then I would just need to work out the problem for probability of 4 and probability of 5, and then I would add those three probabilities together. And that would give me the probability of at least 3 of the 5. Okay. All right, and so they're getting all the same answers here. I think that's supposed to be a multiplication sign. Something's wrong there. See, they get the same thing. All right. So that is our binomial probability formula. It says the first part of it is the number of outcomes with exactly X successes among N trials. The second part says that's the probability of X successes among N trials for any one particular order. All right, and that finishes 5.3.